Module 3, problem number 13. The following data represents the age in weeks at which babies first crawl based on a survey of 12 mothers. You can see right here we have our data set, 52, 47, etc. And here we have the a couple of graphs right here. So first, let's look at part A. Because the sample size is small, we must verify that the data come from a population that is normally distributed and that the sample size does not contain any outliers. Are the conditions for the constructing a confidence interval about the mean satisfied? In this case, we're just going to look at these graphs to tell us that, just from an approximate standpoint. So here we're looking at this graph right here. If this is approximately linear, and by that I mean if these little red dots are in about a line, and in other words, they're not like a big huge curve or outside of those bounds, that's one sign that it's about linear. Here, let's look at this box plot. This is a box plot. Remember this from, I believe, Module 1. This is looking at our quartiles for our data set. Here you have the two middle ones and then the little Q1 and Q4, or Q3, excuse me. We don't see any data points that are falling outside of those areas, so we're going to say there's no outliers. So in this case, we're going to say, yes, the population is normally distributed. All right, let's look at the next part. So the next part says, construct a 95% confidence interval for the mean age at which a baby first crawls. Select the correct choice below and fill in any answer boxes in your choice. So we're going to do this in StatCrunch. If you have any questions about how to do this by hand, we've kind of gone through it a couple times in the general questions forum and in the lesson. But if you have any questions about that, let me know and I can walk through it. Right now I'm going to focus on doing it in StatCrunch because it's a little easier to do it on the screen here. So we're going to click on the icon up here to the right, upper right of the data set, open in StatCrunch. I see it loaded our data set in. So in this case, we are looking to do a 95% confidence interval, and we're looking at the mean. Remember, when we're dealing with the mean, we're looking at the t-distribution. So let's go to t-stats, one sample with data. Again, we have our data set. We don't have summary data. We have our data set. So here we're going to select our column. And see how it automatically populated over here. And then we're going to go down and click confidence interval. And it already said 95, so we know that it's already populated. We're good. So let's click compute, and then we have our numbers. So in this case, it's asking for 1 decimal place. So we know that our lower limit's going to be 37.6, and our upper is going to be 50.1. And since we already know that the population is normally distributed and the sample does not contain any outliers, we can construct that confidence interval. Remember, those are the key, 37.6 and 50.1. Check answer. There we go. What could be done to increase the accuracy of the interval without changing the level of confidence? We could increase the sample size, either increase or decrease the sample size. Nothing can be done, or decrease the sample size. You can always increase the sample size. That's always going to improve your accuracy of your results. So let's click increase the sample size. Check answer. Well done. So just remember that the more data you have, the more accurate results are going to be in most cases, unless you have crazy outlier data, which wouldn't be expected, but that would be the one-off. Typically, more data means more accurate. So if you have any questions about how to do number 13, let me know.